students, so welcome back to my video lecture 8 on S block elements. See students, in the previous video I was talking about the formation of nitrates and sulfates of alkali metals and alkaline earth metals. Under the formation of sulfates, I have missed out one reaction. Please listen to this reaction. See, when metal sulfates are treated with carbon, when metal sulfates are treated with carbon, they form metal sulfides and carbon monoxide. Note this point. When metal sulfates are treated with carbon, they form metal sulfide and carbon monoxide. I have missed out this reaction. So now in this video we will discuss the anomalous properties of lithium and the various compounds of sodium, potassium and calcium. Yes. Students, now anomalous behavior of lithium. Anomalous behavior of lithium. Anomalous behavior of lithium. What is this anomalous behavior? See students, under alkali metals we have lithium, sodium, potassium, rubidium, cesium. Francium is also there, but francium is radioactive element, so we don't discuss its properties here. See, in periodic table, that is under the chapter periodic classification of elements and the periodicity in properties, we have learned that elements belonging to the same group should have same physical and chemical properties, isn't it? So we have learned this statement. Elements belonging to the same group, elements belonging to the same group will have same physical and chemical properties. Will have same physical and what? Chemical properties. Why does elements belonging to the same group, why the elements belonging to the same group will have same physical and chemical properties? Because they have same outer electronic configuration. Since their outer electronic configuration is same, since the outer electronic configuration of all the elements belonging to the same group is same, they'll have same physical and chemical properties. What is the outer electronic configuration of lithium? The outer electronic configuration of lithium is 1s1. This is 2s1. I'm writing the outer electronic configuration. Potassium 3s1, rubidium 4s1, cesium 5s1. Look at here, they have the same outer electronic configuration ns1. Since they have the same outer electronic configuration, all alkali metals, all these elements or all the elements belonging to the same group, they should exhibit same physical and chemical properties. But here lithium exhibits some of the properties which are different from the rest of the alkali metals. Lithium exhibits some of the properties which are different from other alkali metals. This is what we call anomalous behavior of lithium. Not just lithium, all the elements which belong to the second group. Which are the elements belonging to the second group? We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Like this, all these elements which belong to the second period, they exhibit some of the properties which are different from the other elements in their own group. For example, lithium exhibits some of the different properties of when compared to group 1 elements, the other group 1 elements. Beryllium exhibits some of the different properties which are different from group 2 other group 2 elements. Boron will exhibit some of the properties which are different from the other, okay, 13th group elements. Carbon, nitrogen, oxygen, fluorine also will exhibit different properties which are different from, okay, the properties of the other elements in their own group. This is called as anomalous behavior of second period elements. Anomalous behavior of second period elements. We have discussed this in, okay, periodic table, that is classification of elements and periodicity in properties. So I mean to say, even though lithium has same general outer electronic configuration, okay, outer electronic configuration, lithium has certain properties, lithium has some properties, okay, lithium exhibits certain properties which are different from the properties of the rest of the alkali metals. So we call this as anomalous behavior of lithium. Now the question is, why lithium exhibits anomalous properties? Okay, why lithium exhibits anomalous properties? What are the reasons for the anomalous behavior of lithium? What are the reasons? Reasons for anomalous behavior? Yes, there are so many reasons. There are so many reasons due to which lithium, the properties of lithium is different from the properties of the rest of the elements. What are those reasons due to which, okay, lithium exhibits anomalous behavior? Look at here. See, okay, we know among alkali metals, lithium is the smallest atom, isn't it? As we go down the group, the size increases, atomic radius increases, ionic radius increases, etc. Correct? Okay. As we go down the group, size increases, atomic size increases. That means which is the smallest atom? Lithium is the smallest atom. Is it correct? As we go down the group, ionization enthalpy decreases, isn't it? Okay. As we go down the group, ionization enthalpy decreases. That means which one has highest ionization enthalpy? It is lithium. As we go down the group, okay, electron gain enthalpy decreases, correct? So that means which has the highest electron gain enthalpy? It is lithium. Are you getting my point? So one is, what are the reasons for anomalous behavior of lithium? One is small size. Small size. The second one is, okay, high ionization enthalpy. High ionization enthalpy. Okay, high ionization enthalpy. The third one, high electron gain enthalpy. Electron gain enthalpy. Okay, high ionization enthalpy, high electron gain enthalpy. Are you getting my point? Okay, lithium is the smallest atom. Lithium has highest ionization enthalpy. Lithium has highest electron gain enthalpy. And one more important, very important reason for the anomalous behavior is, okay, absence of d orbitals. Absence of what? D orbitals. Okay, absence of d orbitals, very important. What do you mean by this absence of d orbitals? Look at here. If I write the electronic configuration of lithium, what is the atomic number of lithium? It is 3. What is its electronic configuration? 1s2, 2s1, 2p0. Am I correct? There are no 2d orbitals. Is there anything like 2d orbitals? No. Lithium does not have 2d orbitals. That means it cannot expand its octet. It cannot expand its orbital. But if you consider sodium, what is the atomic number of sodium? 11. What is its electronic configuration? 1s2, 2s2, 2p6, okay, 3s1, 3p0, 3d0. Look at here. Sodium has vacant d orbitals. Sodium has vacant d orbitals. That means it can expand its orbitals. Okay, it can expand its orbitals, whereas lithium cannot expand its orbitals. Okay, the covalency of lithium is limited to 4. Look at here. The covalency of lithium, covalency of lithium is limited to 4, whereas the other elements like sodium, potassium, rubidium, cesium, they can expand their covalency beyond 4. Okay, because of the presence of d orbitals in the other elements, and since there are no d orbitals in lithium, lithium cannot expand its covalency. Its covalency is limited to how much? 4. It's limited to 4. So because of all these reasons, small size, high ionization enthalpy, high electron gain enthalpy, and the absence of d orbitals, because of all these reasons, okay, lithium will exhibit certain properties which are different from the properties of other alkali metals. Okay, I hope you understood the reasons for anomalous behavior. Now let us study, okay, in what way, or let us look at the properties of lithium which are different from the properties of the other elements. Okay, yes, well, look at the properties, anomalous properties of lithium. Anomalous properties of lithium. Anomalous properties of lithium. Okay, look at the anomalous properties of lithium. There are so many properties of lithium which are different from the properties of other alkali metals. What is it? We know, yes, alkali metals, okay, alkali metals are soft metals, isn't it? Alkali metals are soft metals, correct? Whereas lithium is a hard metal. Lithium is a hard metal. Are you getting my point? Okay, yeah, alkali metals are soft metals, but lithium is a hard metal, correct? Okay, next, okay, the oxides and hydroxides of alkali metals are strong bases, isn't it? Strong bases, correct? Whereas, okay, lithium oxide and lithium hydroxide, they are quite weak base. They are quite weak bases. Understand? Okay, the oxides and hydroxides of alkali metals are strong bases, whereas lithium oxide and lithium hydroxide is a weak base. Look at the difference here. Okay, yes. Then next, what are the other properties? Okay, yeah, we know alkali metals form ionic bonds. Alkali metals will form what type of bonds? Ionic bonds. Whereas lithium forms covalent bonds. Okay, or else, okay, alkali metals will form ionic compounds. Whereas lithium forms what type of compounds? Covalent compounds. The compounds of lithium are primarily covalent in nature. They are covalent in nature. Are you getting the differences here? Alkali metals are soft metals, whereas lithium is a hard metal. Oxides and hydroxides of alkali metals are strong bases, whereas lithium oxide and lithium hydroxide is a weak base. Okay, alkali metals predominantly form ionic compounds, whereas lithium forms what? Covalent compound. Okay, like that we have so many other, okay, yes, so many other chemical reactions also, okay, in which lithium is different from other alkali metals. Observe this. We know, okay, carbonates of all alkali metals are thermally stable, correct? The carbonates of alkali metals are thermally stable. They are thermally stable, whereas lithium carbonate is unstable. Lithium carbonate, okay, Li2CO3. Lithium carbonate is unstable. Okay, it soon decomposes to give what? Lithium oxide and carbon dioxide. It will soon decompose to give what and what? Lithium oxide and carbon dioxide. Okay, yes. Then Alkali metals, okay, do not combine directly with nitrogen. Directly with what? Nitrogen. Whereas lithium combines with nitrogen directly to form lithium nitride. Okay, to form what? Lithium nitride. Are you getting my point? Okay, carbonates of alkali metals are thermally stable. They are very, very, very stable. Okay, they do not decompose easily. They decompose only beyond 1000 degrees centigrade. But lithium carbonate is unstable. It soon decomposes to give what and what? Lithium oxide and carbon dioxide. All alkali metals, they do not directly react with nitrogen, but okay, do not combine directly with nitrogen, but lithium directly combines with nitrogen to form what? Lithium nitrate. Sorry, lithium nitride. Lithium nitride. And also, observe this. What is it? Okay, yeah. Yes, lithium nitrate, what is the formula? LiNO3. When it decomposes, it gives lithium oxide, nitrogen dioxide and oxygen, whereas other nitrites, the nitrates of other alkali metals, they decompose, giving rise to metal nitrites and oxygen. Metal nitrites and oxygen. See the difference between, okay, alkali metals and alkaline earth metals. So like that, there are numerous reactions. There are numerous reactions. And also one more, okay, lithium bicarbonate, LiHCO3 is liquid, whereas okay, the bicarbonates of other alkali metals are solids. Okay, the bicarbonates of other alkali metals are solids. So like this, we have so many properties of lithium which are very much different from other alkali metals, which we call it as anomalous behavior of lithium. Okay students, I hope you have understood about anomalous behavior of lithium. Any doubts? Okay, so that completes anomalous behavior of lithium. What are the reasons for anomalous behavior of lithium? One is small size, high ionization enthalpy, okay, high electron gain enthalpy, and the absence of d orbitals. Okay, lithium can expand its covalency only to 4, whereas other alkali metals can expand their covalency beyond 4. Okay, and we have so many properties of lithium which are different from other alkali metals. So now students, with this, let us learn some of the important compounds of sodium, potassium and calcium. Okay, yeah, yes. Okay, okay, important compounds of, yes, important compounds of, okay, sodium, potassium and calcium. Okay, important compounds of sodium, potassium and calcium. So which are the important compounds that we're going to study? We will study about sodium hydroxide, then sodium carbonate Na2CO3, okay, sodium thiosulfate Na2, okay, Na2S2O3, sodium thiosulfate Na2S2O3, and then potassium iodide. We will study about potassium iodide. We will study about calcium carbonate and okay, calcium sulfate, and lastly about cement. Okay, these are the important compounds of sodium, potassium and calcium. We have to study the preparations of all these compounds. physical properties of all these compounds and the chemical properties of all these compounds. Okay, so we will discuss the preparation of all these compounds, then okay, physical properties of all these compounds, and the chemical properties of all these compounds. Okay, so three things: preparation, physical properties and chemical properties. So now let us start one by one. Sodium hydroxide, sodium carbonate, sodium thiosulfate, potassium iodide, calcium carbonate, calcium sulfate, that is gypsum and plaster of Paris, and lastly we will talk about cement. Okay, so now I'll be starting with the first compound of sodium. What is it? Sodium hydroxide, NaOH. Sodium hydroxide. Look at here. Okay, sodium hydroxide, NaOH, the first compound of sodium. Okay, what is the chemical name of this? The chemical name of this is, okay, yes, sodium hydroxide. The chemical name of this compound is sodium hydroxide. Okay, but what is the common name of this NaOH? Common name, yes, the common name of this compound is called as caustic soda. The common name of this compound is called as what? Caustic soda. Why is this called as caustic soda? Why sodium hydroxide is called as caustic soda? Because sodium hydroxide is very corrosive in nature. Okay, sodium hydroxide is corrosive in nature. Okay, now look at here. Yes, if sodium hydroxide falls on your skin, what is going to happen? Sodium hydroxide will dissolve all the tissues. Sodium hydroxide will dissolve the tissue present on your skin. It is very, very corrosive in nature. That is why it is called as caustic soda. It is called as what? Caustic soda. I hope you understood. Okay, so what is the chemical name? Sodium hydroxide. What is the common name? It is caustic soda. Fine. Now let us talk about the preparation of this compound. How do we prepare sodium hydroxide? How to prepare sodium hydroxide? Okay, very simple method. A very simple method. Look here. When sodium carbonate, Na2CO3, reacts with calcium hydroxide, CaOH twice. Okay, when sodium carbonate reacts with calcium hydroxide, look here. Okay, I told you how to write the products. Interchange the ions, isn't it? So in sodium carbonate we have sodium ions and carbonate ions. In calcium hydroxide we have calcium ions and hydroxyl ions, isn't it? Just interchange the ions, cation with anion and cation with anion. Therefore, what are the products? Na plus plus OH minus will give what? NaOH, sodium hydroxide. Okay, calcium combines with carbonate to form what? Calcium carbonate, CaCO3. Understood? Okay, so like this, when sodium carbonate combines with calcium hydroxide, it will form sodium hydroxide, which is nothing but what? Caustic soda. Okay, so that is all about the simple method of preparation of sodium hydroxide. Now, what are the properties of sodium hydroxide? Look here. See, this sodium hydroxide, as I told you, okay, it is a strong base. Sodium hydroxide is a strong base. Okay, and it exists as a white crystalline compound. Okay, it exists as a white crystalline compound. crystalline compound. Okay, it exists in the form of pellets. Okay, have you observed camphor pellets? Have you observed camphor pellets? Camphor, okay, yes. So it will be in the form of pellets like this. Okay, it is formed in the form of pellets like camphor pellets. Okay, it's a strong base. It is a white crystalline compound, and it forms in the form of what? Pellets. Okay, it is deliquescent in nature. Deliquescent in nature. What do you mean by deliquescent in nature? Okay, deliquescent means it has, okay, water absorption capacity. Water absorption capacity is called as deliquescent nature. That means when sodium hydroxide is exposed to air, it will absorb the moisture. That is called as deliquescent in nature. Understood? Okay, and also sodium hydroxide has a soapy touch. What do you mean by this soapy touch? Okay, that means it is, okay, if you feel the sodium hydroxide solution, it will be in the form of soap water. Okay, soapy touch. Okay, very slippery type, very slippery type. Understood? Okay, it has a soapy touch. Understood? So sodium hydroxide is a strong base. It's a white crystalline compound. It exists in the form of what? Pellets. Okay, it is deliquescent in nature. That means it has greater water absorption capacity. It has a soapy touch. These are all the physical properties of sodium hydroxide. Physical properties. Now, what are the chemical properties of sodium hydroxide? Well, guys, we have got to understand so many chemical properties of sodium hydroxide. Okay, so many chemical reactions of sodium hydroxide. Okay, let us understand the chemical reactions of sodium hydroxide one by one. Before that, let us list out what are the different chemical reactions that we have got to study under sodium hydroxide. One is reaction of sodium hydroxide with first one. Okay, look here, amphoteric metals. Guys, which are those amphoteric metals? We have discussed it in our previous videos. We have also discussed it under hydrogen. Okay, amphoteric metals like okay, yes, aluminium, zinc, okay, lead, copper, iron. Okay, yes, these are the amphoteric metals. Okay, and also tin is also an amphoteric metal. So we have got to discuss, we have already finished this, don't worry, we have already finished this. Reaction of sodium hydroxide with amphoteric metals. Okay, reaction of sodium hydroxide with carbon dioxide. Okay, reaction of sodium hydroxide with sulfur. Understood? Reaction of sodium hydroxide with, okay, yes, yeah, with halogens. Okay, very important. This is very important. Okay, reaction of sodium hydroxide with metal ions, and lastly reaction of sodium hydroxide with Hg2 plus, okay, Hg plus and okay, NH4 plus. Okay, so we have got to understand all these chemical properties. So students, we will understand these chemical properties in our next video. Okay, yes, thank you so much.